What is a wave? For simplicity reasons of this video, I'm going to call it an oscillating pattern that carries energy through space. There's lots of examples of waves around us. The light you see is a wave. The sound you hear are from waves. Waves at the beach are also, of course, waves. Let's look at some classification of waves. There are two common type of wave classifications that you need to know for your physics class, called transverse and longitudinal. They're also torsional, but that won't be covered in this video. Alright, so here's the two types of waves. We can see transverse is right here, and then longitudinal is right there. So transverse, we can see the direction of the wave is the direction of the black line. So the black line is going in that direction, but the wave is going up and down. Okay, so the oscillation, which is the wave going up and down, is perpendicular to the movement of the wave. So the wave is going that way, but the wave oscillation is going up and down like this. Okay, now longitudinal. So this one, it's parallel. So it's in the same direction. So the wave is going in the direction of the green line there, but the oscillations are in the same direction. So there's compressions right there. A longitudinal wave, it's also called a compression wave because there's compressions and refractions throughout. So that's what makes it a wave. It's like the particles in the medium are compacting and then they're refracting. So that's a compression right there. That's a refraction, compression, refraction. So you can see it's more dense in the areas that are compressed, right? So let's label our waves. So first thing you're going to need to know is the wavelength. So the wavelength is basically the distance traveled for one complete oscillation. So one complete, I'll call it pattern, for example. So one way to do it, you pick one space on the wave. So I'll pick like this point right there, and then you find the same point where the pattern then repeats itself. So we can see it comes down this way, right? So let's find the point where it also comes down like that. So one common mistake is to call that the point, but it's not the point, right? Because this one comes down, that one goes up. So the point wouldn't be there. It would be there instead, okay? And then that means this distance right there, that would be the wavelength, okay? So I'll just label that in there. This is called wavelength. So if you're asked on a test for wavelength, find one point and then find the point that's similar or the exact same thing. It can't be one that looks similar, okay? So like what I was showing before, like this right here, that's not wavelength, okay? But like this point right there, the same point would be that one. So that would also be wavelength. And then this point or that wavelength and that wavelength should be the exact same size. All right, so the next thing we're going to talk about is crest. So the crest is the very top part of the wave. It's the highest point. So like that, for example, is a crest. Okay, that's a bad. I'll write that better. So that right there is a crest. And so is that right there. So both those points are crests. So the next point is a trough, which it's kind of like the crest, except the opposite. So the crest was at the very tallest point. This one's at the very shortest point. So it's called a trough. You can see it's what it's spelt like. And then it's at any point that's the smallest, or yeah, like the furthest down. So there's that point, and there's one other right there. Any point that's at the lowest. And then next one is amplitude. So this is the last one. So amplitude is basically from the equilibrium point to the highest point or to the lowest point. So like this, that's the equilibrium, right? The line right there. So if you come all the way up there, that length right, that length right there, that is the amplitude. And then same with right here, all the way down there, that's also amplitude, okay? So those 2 points are amplitude. Those two lengths are amplitude. And then final thing is going to be period and frequency. So you can't see the period or frequency, but I'm still going to be talking about it. So period is how long it takes for the wave to do one wavelength, so one complete oscillation. So how long it takes to go from like this point to that point, for example. And then frequency is the number of wavelengths or the number of times it oscillates in a second. So you can write period as t. So let's say t was equal to 0.25 seconds. So a quarter of a second. Okay? It's a bad. Let me draw that S again. 0.25 seconds. So that means the wave took 0.25 seconds to go from this point to that point, right? Therefore, we can find the frequency. So frequency is number of oscillations in a second, right? So you're going to write F for frequency, and then it's described as 1 over T, okay? So you can replace 0.25 here. You get F equals 1 over 0.25, which would just equal 4, right? So equal 4. And then the units for this, they're called hertz. So it's like H and then Z, hertz. All right, then let's do longitudinal now. So longitudinal, it's very similar, but it's a little bit different. So there isn't any like crest in this one. So there's compressions and then there's refractions, right? So we already kind of talked about that. So like those are all compressions. I'll write that in. So these are compressions right there. And then these are refractions, right? So those two things are refractions right there. And then the wavelength for, sorry, I'll draw it here. I'll circle the refraction. So refraction, 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 right? There's another refraction. And then compression in the red, compression, compression, compression. And one more compression right there. And then for the wavelength for a longitudinal one, so basically you're to take the middle point of a compression here, so like for example like right there, and bring it to the middle point of another compression, and then that's the wavelength. So that right there would be the wavelength. There are two common types of waves: mechanical and electromagnetic. Electromagnetic waves can travel through a vacuum. The reason for this is a little complicated, but basically an electric field induces a magnetic field and vice versa. So an electromagnetic wave is induced by itself, so it's able to travel through space without a medium. EM waves are on a spectrum, with radio waves on the least intense side to gamma rays on the most intense. It goes from largest wavelength to shortest wavelength. Near the middle is visible light, which we can see with our eyes. Mechanical waves. Mechanical waves are waves that travel through a medium. They need a material to transfer the energy. For example, sound needs air to travel. That's why you can't hear anything in space, because there's no air. There's nothing to transport the energy.